So this is 11-2 chi-square test, the alpha list. And again, I think these slides are really helpful. Sometimes you go by them too fast. What do you have to do? Hypotheses, expected counts, two-way table. Well, we did two-way tables when we talked about independence in the fall. We're coming back to the same two-way tables. Check the conditions, degrees of freedom, p-value, test of homogeneity, test of independence. They're both done the same way. So the issue is, if you're not sure, you don't even know what the difference is yet. If you're not sure whether it's a test of homogeneity or a test of independence, don't be specific. Just say chi-square test. Don't put yourself out there and guess. There's a difference, even though the tests are carried out the same way. So we're back to the template. What do you need to do? You can't have anyone in the room fail this up. Unacceptable. When you get to the inference question, you write the conditions. Now you could foul this up. If you mess up one of the conditions, that's fine. But if you omit the conditions altogether, that's not good. The conditions, the null and the alternate. The test statistic, which in this case would be chi-squared. The degrees of freedom and the p-value. And then do we reject or do we fail to reject? So just a reminder, what is the definition of the p-value? And don't break eye contact. What is the definition of a p-value? That's how you get called. No one? No one in the room knows the definition of p-value. Megan. Or more extreme. You got or more extreme. Yes. The probability of getting the test statistic that you got. For this thing, it is for this test, it's the chi-squared value. The probability you got your chi-square value or more extreme. By chance alone, had the null been true. That is the p-value. Once we get the p-value, what do we do with it? You compare it to something, which would be what? The alpha level, very good. And if the p-value, now listen to this, if the p-value is larger than the alpha level, what do? We fail to reject, exactly, 3 to y, because you're in the body of the curve. When do we reject? When the p-value is smaller than the alpha level. Now, ready? I understand something you probably don't clue into. It's hard to answer those questions auditorily. When somebody asks you a question, you're not saying a picture, it's hard to answer. Yes? So you draw a picture. And that means this. For the p-value, for chi-squared looks like that. If the alpha level's here, we're saying if the p-value is larger than the alpha level, we're in the tail. Reject the null. If the p-value is smaller than the alpha level, F2R. But it's way easier to answer this question by looking at that picture than it is for me to just call out the question, you to answer it. You need to do that. You need to draw a visual aid. So, moving on. So here's an example. If you have background music on in your restaurant, could you influence what kind of meal the people buy? So this is some magic restaurant that has French, Italian, and other entrees. Does that make sense? No. Why would you pick a motif for your restaurant? It's trying to be all things to all people. So the null is there's no difference for what the entree order is compared to the music. The alternate is there is a difference. So now we've got this. You got a two-way table. And if you read the two-way table, the rows are the meals and the columns are the music. Okay? And there are 243 orders. So what they do? Well, the music was almost the same, like 84 days, 84 like seatings. They had no music. 75 they had French music, and 84 they had Italian music. Right? They had, roughly 240 seatings. 243 seatings, and that was the distribution of music. And then the sum of the rows is the distribution of the meals. So you notice this. If they have French music playing, only one person ordered an Italian entree. And then here's a bar graph for the columns. No music, French music, Italian music. So what happened? Well, when you had no music, people chose other meals. When you had French music, French or other, they're pretty close. When you had Italian music, Italian was the third most popular meal order, but it was higher than for the other scenarios. So could that be attributed to chance alone, or is there evidence that the music influenced these people when they ordered their meal at this restaurant? So what are we going to do? Well, it's a z-test because it's proportions. It's not the mean numbers. We're not issuing the mean orders. We're saying what proportion of meals were those choices. What proportion were French? What proportion were Italian? What proportion were others? So we're back to the z-test. Remember we did tests of means? They were t-tests. We're back to z-tests. So in order to avoid a type 1 error, we're going to combine the z-test into one test. So here's the expected outcomes, which we did this. If we want to know what belongs in row 1, column 1, we take the sum of row 1, the sum of column 1, we multiply them and divide by the grand total. And we would get 34 and 2200ths. We expect that cell to be 34.22. And we could do that 9 times to get all the expected counts. Make sense? We did this in the fall. It is row times column divided by the sum, the grand sum. Now you're going to see you don't have to do that 9 times. The calculator will do it for you. But you may get a multiple choice question where you have to do it once. And say what belongs in this cell. So you can't 100% rely on the technology. You have to understand where these numbers are coming from. So they're the expected counts. They're for you. Do not round them. I thought we had a slide that had the expected counts on it, but I guess not. All right. So that's as far as we're going to go on the PowerPoint for today. So what do we got? We got a chi-square goodness of fit test. That was 11.1. Homogeneity and independence are 11.2. The difference between them is if you had how many populations, how many variables. We will get to that. I'm not really worried about that now. But this is what I'm concerned about. Do you understand this? That what we're doing here, if you go to your calculator, we go to stat test, and we see 6, ready? 2 proportion z-test. 6 is related to C. Because a 2 proportion z-test, a chi-square is a 2 or more proportion z-test. If you had 2 proportions and you did a chi-square test to them, instead of doing stat test 6, you would get the same p-value. But if we had 3 proportions, you couldn't do stat test 6. You'd have to do the chi-square test. What we're trying to point out to you is this. This is greater than or equal to 2 proportion z-test. And z-tests are tests of proportions. That's what's going on here. Okay? And then the expected number, what goes in there? Sum of the row times sum of the column divided by the grand sum. You're familiar with that. You're familiar with that from the fall. That's where the expected counts are coming from. So we're just going to pause the video and send you to 2 questions. (27) and 29. (27). Well, just by looking at this, what do we say? Well, look, if you have the color paper, you're more likely to respond to that color candy. Okay, the control group was closer to 50% for each candy color, but you know, you can't tell if that was statistically significant or not. So 29, what is the null and the alternate? Well, the null is the distribution of candy color is the same for each of the surveys. The alternate is it's not the same. Then what are the expected counts? Well, I only did one expected count. I said the sum of the row, the red row, times the sum of the red column divided by 60 should give you 8.68 2/3. Okay? And then it asks for the test statistic and all of the expected counts. Well, we're going to do this together. So everyone go here on your calculator. Go to matrix, which is second inverse key, second x to -1. Sorry, inverse, second x to -1. And what? Go over to edit and type 1. So in matrix A, this is why it's helpful to be good at the attendance challenge, because you have to put in the rows and the columns correctly. There are 2 rows by 3 columns in the textbook. This is the observed candy. Yes? Do not put the totals in the matrix. Just the entry. So in your calculator, you should have a 2 by 3 matrix A and put in those numbers. But they're the numbers right from the problem in the textbook. That's how the information was presented to you. Okay? Now, this is what's really helpful. We're going to go here. Everybody done? Type them in. Second quit. Stat. Test. Everybody's got this. Chi-square test. You click on that, which is really cool. And on the observed, I put second matrix 1, and that puts A there. Yes? But then it calls for expected. You just type second matrix 2, but that's empty. Doesn't matter. The calculator is going to fill it out for you. So you put the empty matrix there. You scroll down to calculate. Now that's what you saw on the PDF. The chi-square test statistic is 6.65. Well, that doesn't mean anything until we compare it to the critical value. So we got this. Just to be consistent, we'll take it to 3 decimal places like calculus, but you don't need to do that. But they're telling you in the test what the p-value is. The p-value is less than 5%. So we should reject the null. But now look what happens. Go to go to second quick. Matrix. Look at B, just appeared there. Scroll down, type 2. There's matrix B. It's hard to read, so I'm going to go to mood. Let's just go to 2 decimal places for now. Second quit, second enter. There's the matrix, the expected matrix. The calculator does it for you. So remember that number we got on the PDF, the 8 2/3? We showed you where it came from, but if you run the test, it does it for you. There, look at the same thing. The p-value is less than 5%. So we would reject the null. Now, if you are at home, you are dismissed to do the exit ticket. Now, tomorrow we have office hours. If you're interested in doing that, send me an email. If you're at home, Thursday we have AP lunch. You're invited to that.